Hello and welcome to another video from Adams Academy, an expert online tutoring service for high school mathematics. In this video, we are going to look at questions from the 2016 CBSE question paper from the chapter Areas Related to Circles. Let's look at the first question, which is for 3 marks. Find the area of shaded region in figure 4 where a circle of radius 6 centimeters has been drawn with vertex O of an equilateral triangle OAB of side 12 centimeter. Use pi is 3.14 and root 3 is 1.73. So the circle is of radius 6 centimeters. Let's mark that somewhere. This radius here is 6. And the equilateral triangle OAB has a side of 12 centimeters. So this AB is 12. How will you find the area of the shaded region? Area of the shaded region will be equal to area of the sector on top. So this is the major sector which has been shaded on top, plus area of the equilateral triangle, and then you have to subtract the area of the minor sector because that hasn't been shaded. First let's find the area of the major sector. You know that this angle here is 60 degrees because the triangle is an equilateral triangle. So angle AOB is 60 degrees. So if you look at the major sector at the top, so we are talking about this shaded sector here. The angle for that sector is going to be 360 degrees minus 60 degrees because you have to subtract the angle of the non-shaded part. So the minor sector here is not shaded and that has an angle of 60 degrees. So for the major sector, the angle is going to be 360 minus 60, that's 300 degrees. So here the area is going to be theta by 360 into pi r square. Theta here is 300 degrees. So that's 300 by 360 into pi r squared. R is 6 centimeters from the question. Now area of the triangle is root 3 by 4 a square, where a is the side. So that's the formula to find the area of an equilateral triangle. Root 3 by 4 into 12 squared in this case. Minus. Now let's find the area of the minor sector. So the minor sector is the sector here that is not shaded. That has an angle of 60 degrees because that is one of the angles of the triangle which is equilateral. So the area of that sector is going to be theta, which is 60 by 360 into pi into 6 squared. Now from the first and the third terms, you can take a few common factors out. You can take pi into 6 squared by 360 out, and that becomes 300 minus 60. And for the triangle, it is root 3 by 4 into 144. If you do these calculations using the value of pi and root 3 given in the question, the answer will be 137.64 centimeter squared. Let's try the next one. This is also a 3-mark question. In figure 5 is a chord AB of a circle with center O and radius 10 centimeter. The radius here is 10 centimeters. That subtends a right angle at the center of the circle. The right angle is already marked in the figure. Find the area of minor segment AQBP. That's a shaded minor segment here. Hence find the area of major segment ALBQA. Right, how do we do this? To find the area of the minor segment, you need to find area of sector minus area of triangle OAB. Now this sector is actually a quadrant of the circle because the central angle is 90 degrees. So it's 1/4 of the circle. So area is going to be 1/4 of pi r squared. Pi is 3.14. R is 10. So r squared is 100. Minus area of triangle is going to be, it's a right triangle. So half BH. Half into base and height are both 10. So that's the area of the triangle. So it's going to be 314 by 4 minus 100 by 2. And if you do the calculations, you will get 28.5 centimeters squared. That's the area of the minor segment. We also need to find the area of the major segment. How will you find the area of the major segment? Area of the major segment is going to be area of the circle minus area of minor segment. Area of the circle is pi r squared, or 3.14 into r is 10, so r squared is 100, minus area of minor segment, we just found that out, that's 28.5. And if you do this calculation, you will get 285.5 centimeters squared. That's the area of the major segment. Let's try the last question from 2016. This is a 4-mark question. Find the area of the shaded region in figure 8 where arc APD, look at the figure, arc APD, this is the big semicircle, arc AQB, the small one here, arc BRC, this one at the bottom, and arc CSD, this one here, are semicircles of diameter 14, 3.5, 7 and 3.5. Right, so how will you find the area of the shaded region? You can break the shaded region up into 2 parts, above and below this line here, right? So if you look at the shaded region above this line, that consists of the big semicircle. I'm talking about the semicircle APD, and then you have to subtract the 2 small semicircles here because they are not shaded, right? So if you look at the big semicircular region with diameter AD, the area of that semicircle is going to be half into pi r squared. Let's just keep it as pi. We'll substitute pi at the end after all the calculations, after all the simplification. So this is half pi r squared, or half into pi into, the radius of that semicircle is 7 centimeters because the diameter is 14. So that's 7 squared. Okay. And then you need to subtract the 2 semicircles, these 2 semicircles. So that makes a full circle, right? You're subtracting 2 semicircles, or you might as well subtract a whole circle. So that's pi r squared. R in this case is 3.5 by 2, right? Because the diameter is 3.5. So R is going to be 3.5 by 2. So this expression here, this one, gives you the area of the shaded part above this red line. Now we need to add this semicircular region, and that is going to be half into pi into the radius of that semicircle, this one, is 7 by 2. So that's 7 by 2. So if you calculate this whole expression, that's half into pi into 7 squared minus pi into 3.5 by 2 squared plus half into pi into 7 by 2 whole squared, you are going to get the answer. You can take pi out as a common factor. So that's going to be 49 by 2 minus 12.25 by 4 plus 49 by 8. If you do this calculation, you will get 196 minus 24.5 plus 49, which is 22 by 7 into 220.5 by 8. So if you do those calculations, you will finally get 86.625 centimeters squared. For more revision videos, please like our Facebook page and subscribe to our YouTube channel. Thanks for watching.